At first glance, this looks like quite an intimidating question because you've just got tables and tables of numbers. But if you take it one step at a time, you can see that there's two investigations happened here. One of them, she's investigated the resistance of a component when you change the temperature of it, and the other one, she's shone a light on it and compared the resistance of the component to how much light is being shone on it. So if we take a look at component A, in the first test we can see that as the temperature increased, the resistance decreased, and if we look at the same component in the second test, we can see that as the light increased, the resistance pretty much stayed the same, varied around 100 ohms. So whatever component it is, it must be sensitive to temperature, but not to light. Now the only one that we know that does that is a thermistor. The second component, component B, we can see when you change the temperature, the resistance stays approximately constant, around about 50 ohms. But when we increase the light intensity, we can see the resistance drops down from 76 all the way down to 8. So this must tell us that this is sensitive to light. We only know of one component that is sensitive to light, and we call that an LDR, light-dependent resistor. And our final component, component C, regardless of whether you change the temperature or the light intensity, stays fixed around about 100 ohms. So it must be a fixed resistor, or we can just call that a resistor. The second part of this question was a bit tricky. It asked for a bit of information to think about how the test was conducted. It says Judy repeated her tests 3 times. Well, we don't have any evidence that she did that, but we don't know if she didn't either. We don't have any repeats shown, so we're going to have to say we cannot tell. The second one says that Judy had an outlier in her results in the temperature experiment. Well, if we look at the temperature experiment, we can see that all the results are fairly similar for component B, component C, and within component A we've got a fairly regular trend of the results halving every time we increase the temperature by 10 degrees C. So I'm happy to say that there is no outlier in those results. The third one says that Judy had an outlier in her results in the light intensity experiment. Well, we can just look straight at component B here. We can see that down at the bottom of the results, we go from 14 to 19 and then back down to 8. That looks like an outlier to us from what we know about LDRs. We wouldn't expect it to behave like that, so we're going to call that an outlier. The third one that says the temperature in the light intensity experiment was approximately 20 degrees C. Well, at 20 degrees C we would expect our thermistor to have a resistance of around about 100 ohms. If we have a look at our thermistor, component A, we can see that it does have a resistance of 100 ohms all the way through the experiment. So yes, it does appear that the temperature in the light intensity experiment was around about 20 degrees C. The final question, the light intensity in the temperature experiment was approximately 200 lux. Well, we can see that the light-dependent resistor at 200 lux had a resistance of around about 32 ohms, yet throughout the temperature experiment the resistance was around about 50 ohms. So that would actually suggest that the light intensity was actually somewhere closer to 100 lux, which would correspond. 100 lux is around about 50 ohms. So we're going to have to say false. The light intensity in the temperature experiment was not 200 lux.